Article 410.15b specifically mentions luminaires, light fixtures, and supply conductors. It does not explicitly include traffic signal items such as pedestrian signals, push buttons, or vehicle loop detectors. Therefore, this article alone does not provide a clear basis for using grounded signal poles as a raceway for traffic signal items. Other articles to consider include Article 225.19. This article states that where traffic signal conductors are installed in metal raceways and are accessible to pedestrians, the raceways shall be grounded. Additionally, Article 300.3b2 requires that conductors enclosed within a raceway from the point of supply to the point of utilization shall be protected from overcurrent by a single overcurrent protective device located at the point of supply. Based on the available articles, it is reasonable to conclude that using grounded signal poles as a raceway for traffic signal items may not fully meet the requirements of the National Electrical Code. Specifically, Article 225.19 requires that traffic signal conductors be installed in grounded raceways, but it does not specify the type of raceway. Article 300.3b2 requires a single overcurrent protective device at the point of supply, but it does not specifically address how this should be implemented in the case of grounded signal poles. To address these concerns, consider the following alternative approaches. Firstly, use a separate grounded raceway. Install a separate, non-metallic raceway or conduit to enclose traffic signal conductors. This would ensure compliance with Article 225.19. Secondly, use a dedicated overcurrent protective device. Install a dedicated overcurrent protective device such as a circuit breaker at the point of supply for traffic signal conductors. This would satisfy the requirements of Article 300.3b2. The local authority having jurisdiction may have specific interpretations or requirements regarding this issue. It is advisable to consult with the authority having jurisdiction before proceeding with any design or installation work. When designing and installing roadway lighting and traffic signal installations, electrical engineers and contractors must adhere to the National Electrical Code to ensure safety and compliance. A common question arises regarding the use of grounded signal poles with a handhole as a raceway for traffic signal, pedestrian push button, and vehicle loop detector wiring. This practice needs careful evaluation against the NEC requirements. Article 410.15b addresses the use of metal poles to support luminaires, light fixtures, and as a raceway to enclose supply conductors. However, it doesn't explicitly include traffic signal items. The interpretation of this article is crucial in determining whether it can be applied to traffic signal installations. While the article permits using metal poles as raceways for supply conductors, it specifically mentions luminaires. The ambiguity arises when considering whether traffic signal items can be included under this provision. To clarify, it is essential to examine other relevant articles within the NEC. Article 225.19 provides guidance on traffic signal conductors. It states that where traffic signal conductors are installed in metal raceways and are accessible to pedestrians, the raceways shall be grounded. This article emphasizes the importance of grounding metal raceways that house traffic signal conductors, particularly when they are accessible to pedestrians. However, it does not explicitly approve the use of signal poles as raceways. Article 300.3b2 addresses the protection of conductors within raceways. It mandates that conductors enclosed within a raceway from the point of supply to the point of utilization shall be protected from overcurrent by a single overcurrent protective device located at the point of supply. This requirement is critical to ensure that the electrical system is protected from faults and overloads. Given these articles, it is reasonable to question whether using grounded signal poles as raceways for traffic signal items fully complies with the NEC. While Article 225.19 requires grounding of metal raceways containing traffic signal conductors, it doesn't specify the type of raceway. Moreover, Article 300.3b2 necessitates a single overcurrent protective device at the point of supply, but it does not provide explicit guidance on how to implement this in the context of grounded signal poles. To ensure code compliance, alternative approaches should be considered. Firstly, using a separate grounded raceway can provide a clear path for traffic signal conductors. This involves installing a separate non-metallic raceway or conduit to enclose traffic signal conductors, ensuring compliance with Article 225.19. Secondly, a dedicated overcurrent protective device can safeguard the traffic signal conductors. This involves installing a dedicated overcurrent protective device such as a circuit breaker at the point of supply, satisfying the requirements of Article 300.3b2. Consulting with the local authority having jurisdiction is crucial. The authority having jurisdiction may have specific interpretations or requirements regarding this issue, and it is advisable to consult with them before proceeding with any design or installation work. In summary, while Article 410.15b allows metal poles to be used as raceways for luminaires and supply conductors, its applicability to traffic signal items is not explicitly stated. Articles 225.19 and 300.3b2 provide additional requirements for traffic signal conductors and overcurrent protection. To ensure compliance, consider using separate raceways and dedicated overcurrent protective devices, and always consult with the local authority having jurisdiction. Let's delve further into the specific requirements and considerations for traffic signal installations to ensure adherence to the National Electrical Code and best practices. Understanding the nuances of these regulations can prevent potential hazards and ensure the reliable operation of traffic signal systems. Article 410.15b of the NEC, as previously mentioned, permits the use of metal poles to support luminaires or light fixtures and serve as a raceway for supply conductors. However, the key question remains whether this allowance extends to traffic signal items such as pedestrian signals, push buttons, and vehicle loop detectors. The wording of this article is specific to luminaires and supply conductors, and it does not explicitly include other types of electrical equipment commonly found in traffic signal installations. Therefore, relying solely on Article 410.15b to justify the use of signal poles as raceways for all traffic signal components may not be sufficient. Other NEC articles must be considered to provide a comprehensive understanding of the code requirements. Article 225.19, which addresses traffic signal conductors, stipulates that where traffic signal conductors are installed in metal raceways and are accessible to pedestrians, the raceways must be grounded. This requirement highlights the importance of grounding to protect pedestrians from potential electrical hazards. However, it does not explicitly endorse the use of signal poles as raceways. The article focuses on the need for grounding when metal raceways are used, regardless of their specific type. Article 300.3b2 is crucial for understanding overcurrent protection requirements. This article mandates that conductors enclosed within a raceway from the point of supply to the point of utilization must be protected from overcurrent by a single overcurrent protective device located at the point of supply. This requirement is designed to prevent damage to equipment and wiring due to excessive current flow, which can result from short circuits or overloads. When applying this requirement to traffic signal installations, it is essential to ensure that each circuit is properly protected by a dedicated overcurrent device. Considering these articles collectively, it becomes evident that using grounded signal poles as raceways for all traffic signal items may not fully meet the intent and requirements of the NEC. While signal poles may be suitable for certain supply conductors, the code does not explicitly authorize their use for all components of a traffic signal system. Therefore, alternative approaches should be explored to ensure compliance. One effective approach is to use a separate grounded raceway for traffic signal conductors. This involves installing a dedicated non-metallic raceway or conduit specifically for enclosing traffic signal conductors. By segregating these conductors from the signal pole, compliance with Article 225.19 can be ensured. The separate raceway provides a defined and grounded pathway for the electrical wiring, reducing the risk of electrical hazards. Another approach is to implement a dedicated overcurrent protective device for traffic signal conductors. This involves installing a separate circuit breaker or fuse at the point of supply for these conductors, satisfying the requirements of Article 300.3b2. The dedicated overcurrent device provides specific protection for the traffic signal circuits, preventing damage from overloads or short circuits. In addition to these technical solutions, it is essential to consult with the local authority having jurisdiction. The authority having jurisdiction is responsible for interpreting and enforcing the NEC within their jurisdiction. They may have specific interpretations or requirements regarding the use of signal poles as raceways, and their guidance should be followed to ensure compliance. Consulting with the authority having jurisdiction early in the design process can prevent costly rework and ensure that the installation meets all applicable codes and standards. Furthermore, it is important to consider the physical and environmental conditions of the installation. Signal poles are often exposed to harsh weather conditions, including rain, snow, and extreme temperatures. These conditions can affect the performance and reliability of electrical wiring and equipment. Therefore, it is essential to use materials and methods that are suitable for the specific environment. This may include using weatherproof enclosures, corrosion-resistant conductors, and other protective measures. Regular inspection and maintenance are also crucial for ensuring the continued safety and reliability of traffic signal installations. Over time, wiring and equipment can deteriorate due to exposure to the elements or other factors. Regular inspections can identify potential problems early, allowing for timely repairs and preventing more serious issues from developing. Maintenance tasks such as tightening connections, replacing damaged wiring, and testing overcurrent devices should be performed on a regular basis. By following these guidelines and consulting with qualified professionals, engineers and contractors can ensure that traffic signal installations are designed and installed in accordance with the NEC and best practices. This will help to protect the public from electrical hazards and ensure the reliable operation of these essential systems. The National Electrical Code is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. Understanding and adhering to these standards is essential for ensuring the safety of people and property. In the context of traffic signal installations, several NEC articles are particularly relevant. As previously discussed, Article 410.15b addresses the use of metal poles to support luminaires, or light fixtures, and serve as a raceway for supply conductors. However, its applicability to traffic signal items is limited. Article 225.19 focuses on traffic signal conductors and requires that metal raceways containing these conductors be grounded when accessible to pedestrians. This requirement is intended to prevent electrical shock hazards. Article 300.3b2 mandates that conductors within a raceway be protected from overcurrent by a single overcurrent protective device located at the point of supply. This requirement is designed to prevent damage to equipment and wiring due to excessive current flow. In addition to these articles, other NEC provisions may also apply to traffic signal installations. For example, Article 314 addresses junction boxes, pull boxes, and hand toll enclosures. These enclosures are commonly used in traffic signal systems to provide access to wiring and connections. The NEC specifies requirements for the size, construction, and installation of these enclosures to ensure their safety and reliability. Article 392 covers cable trays, which are often used to support and route cables in traffic signal installations. The NEC specifies requirements for the design, installation, and grounding of cable trays to ensure their structural integrity and electrical safety. Article 408 addresses switchboards and panel boards, which are used to distribute power to various circuits and traffic signal systems. The NEC specifies requirements for the construction, installation, and overcurrent protection of switchboards and panel boards to ensure their safe and reliable operation. When designing and installing traffic signal systems, it is essential to consider all applicable NEC requirements. This requires a thorough understanding of the code and attention to detail. It is also important to consult with qualified professionals such as licensed electrical engineers and contractors who can provide expert guidance and ensure compliance. In addition to the NEC, other codes and standards may also apply to traffic signal installations. These may include local built-in codes, transportation department standards, and industry best practices. It is important to be aware of all applicable requirements and to ensure that the installation meets or exceeds them. Proper planning and design are essential for ensuring the safety and reliability of traffic signal installations. This includes selecting appropriate materials and equipment, designing the electrical system to meet the load requirements, and providing adequate overcurrent protection. It also includes considering the environmental conditions and implementing measures to protect the wiring and equipment from weather, corrosion, and other hazards. During installation, it is important to follow all manufacturers' instructions and to use proper wiring methods. This includes ensuring that connections are tight and secure, that conductors are properly insulated, and that grounding is properly installed. It is also important to inspect the installation thoroughly before energizing the system to ensure that there are no defects or hazards. Regular inspection and maintenance are essential for maintaining the safety and reliability of traffic signal installations. This includes inspecting the wiring, equipment, and enclosures for damage or deterioration, testing overcurrent devices, and cleaning and lubricating moving parts. It is also important to keep records of inspections and maintenance activities to track the condition of the system and to identify any recurring problems. By following these guidelines and adhering to all applicable codes and standards, engineers and contractors can ensure that traffic signal installations are safe, reliable, and compliant. This will help to protect the public from electrical hazards and to ensure the smooth and efficient operation of these essential systems. The design and installation of roadway lighting and traffic signal systems are complex tasks that require a thorough understanding of electrical engineering principles, the National Electrical Code, and local regulations. By paying close attention to detail and following best practices, engineers and contractors can create systems that are safe, reliable, and efficient.